So, your test is tomorrow.
How about Wednesday?
No, tomorrow works for me. All right.
Wednesday or Thursday?
What's the
No, you are, because I still have.
Yeah, that's the one. All right. So, slope fields, the newest stuff. Really, it's just two skills. Matching a slope field to an equation and vice versa, and making an actual slope field. You can expect that that would be used in conjunction with solve a differential equation problem like you had on the extra practice. So, if you went over the fun sheet well, and learn from it well, and I'll give it back to you. If you did it as makeup, then you should be in pretty good shape. That's a pretty good bet. I haven't finished the test yet. That's a pretty good bet for a free response as a differential equation question. The good news is if you feel rusty or iffy on that, I have several problems I could pull from. So if you came in 7th hour, I could probably give you an 8th and you're supposed to practice. This is 6th period. 103 is delta epsilon proof. I doubt I'll be able to get through a whole delta epsilon proof in addition to a whole test. So I think it would be more like something greater, helpful, like a linear delta epsilon proof, or given this problem, what's your delta kind of thing. And then I can just, if you have the right, let's just practice one, shall we? So say I asked, what is the limit as x goes to 2 of x squared minus 4. Actually, let's go x squared minus 1. We know, obviously, that that is 3. The question might be the delta to prove the limit is 3 is ... and you find that delta. Go. I'm not doing the one on the practice. I'll leave that for you to try to remember. If you want to throw a question on me, I'll get you started. Conclusion, let delta equal epsilon over 5. Right? Okay. Now the question is, how long is this taking you? As I'm going to try really hard this time. I think I said it every time, but I really am going to try this time to make the test shorter, so you're not, just throwing crap down. I mean, you can think a little bit. But this would be a problem where I wouldn't expect, there really are going to be two types of problems. One that you've not seen before, you have to think your way through a little bit, and I expect that. But there's some that I expect you to just kind of know, and you should see it and say, I recognize that problem, here I go. And you just go. This would be one of those. Is it? Were you able to do that fairly quickly? Okay. So 103, 102. 102 is recognizing E. I had more than a few people on a problem. It was actually a sequence problem, which is not on the test. But the problem was this. Does this converge? And people said yes,
converges because limit is 1. Now that shows that you are not going to do well tomorrow, because that limit is most definitely not 1. Is the very definition of e. Okay? So if you don't recognize that the limit as u goes to infinity of 1 plus 1 over u to the u is e, you best study that right fast. Okay? And then you better be able to manipulate it, of course. Different numbers thrown in different places. We practice. So that would be something you would study. I'm not big on studying on math, but there are some things you can study. That's one of them. 101 is also same famous limits, sign, and so on. You can also study set 100 is antiderivatives of all the 4 trig functions. That would also be, if you don't know this, it'd probably be a lot quicker if you had it memorized so you didn't have to show the whole process if you didn't do the whole process. So do you know that derivative? Antiderivative. Secant u plus tangent u. If you didn't know that, you best study that. Okay? There are lots of different problems. That would be a couple different small problems on the front. For example, this, gosh, if you missed that, I would cry bitter tears. Tangent, that's the derivative of tangent for Pete's stinking sake. This is a small skip from that. What's that? Secant squared minus 1 by identity, then antiderivative of each piece, right? All those secant cubed or tangent cubed. Secant cubed is actually a mess, never mind. Tangent cubed, something like that. Lots of different problems in there. Look at your notes, and you'll be all set. 99 is differentials. Some people have no problem with differentials. Some people have a great deal of problem with differentials. If you look at your notes, I'm thinking I'll probably pull an example from your notes or something like it. The one I gave you as a practice problem is pretty challenging. I heard that you wanted harder practice problems, so I gave you a fairly hard practice problem in the test practice. Make sure you can do differentials. Start by making clear that you show the appropriate work. I have to. This should be in every differential problem or some form thereof, whatever it might be, depending on the problem. dv equals, that is the idea. If you don't have that in your work, then you really don't know what's going on, okay? You should also understand relative and percent error. Yes?
Do we have to say like delta V is approximately equal to dV?
You should. I don't have a point built in for my rubric, but that to me is also part of the idea. Good question. Keep in mind there are also 2 types of problems. One where you estimate the change and one where you actually estimate the new value. Read carefully. If I say, for example, estimate the square root or the cube root of 65, you're not going to just do dy. You're going to actually do the cube root of 64, the clean, plus the expected change. So there's estimate the change versus estimate the new value. You with me? Okay. And then last but not least, 98. Oh, 98. Oh my, poor 98. Between you and I, we made a mess of 98. That's the day I didn't do notes because I had a meeting and I figured, it's no big deal, they'll just get it, and of course you did not. So here's the problem. It was on the test, on the quiz on Friday, and it was confounding to see your estimate for natural log of 2. It's a pretty sure sign if a regularly very smart person has been taken into the weeds and turned around in a circle with a blindfold on so many times that you are absolutely lost, and so that in your work, amazingly, you estimated the natural log of 2 with something like 1/3 over 2, natural log of 1 plus natural log of 3/2 plus natural log of 2. You're using natural log of 2 to estimate natural log of 2.
even more fascinating is that the natural log of 2 is actually itself plus stuff. That's amazing. How is that? That's like new math. You should write that down because you just invented some stuff. That's cool. Okay? When you estimate, it was fine for me, it was fine up to here, but it was abundantly clear that you have no idea what curve you are finding the area under. Natural log, by definition, I wrote this on your notes, by definition, it segued into, from the inverse of E to the area under 1 over x. Oops. I saw that. Okay. Sorry. Okay. So if you have the 1 over curve and you look at 1 to some point, this area represents the natural log of whatever you end at. So natural log of 2 is the area under 1 over x from 1 to 2. Natural log of 10 would be the area from 1 to 10. It's not the area. Natural log of x is not the area under natural log of x. Okay, that's it's ridiculous. It's no. Okay. I'll also say this. I'm throwing you lots of bones here. I'm throwing you help. This is good stuff here, okay? If in the error bound you want to talk max, for these problems, the max is always the same thing. It's always 2. Always 2. Okay? Now, the reason is because it's the max of the second derivative here. Now, I'm not saying max for all trapezoid problems. I'm saying max for this problem. Understood? Okay. It's because the function is 1 over x. Thank you for not saying natural log this time. Okay. The curve you're finding the area under is 1 over x. If f is 1 over x, then f prime is negative x to the negative 2, and f double is 2x to the negative 3. Now this is always decaying. Now assuming then that the x value is greater than 1, which actually doesn't have to be, I shouldn't say it's always 2, but x is greater than 1, then the greatest value will always be when x is at its least, which is at 1. And so the max on any interval where it's going 1 to higher number x must always be 2. Okay, so let's be clear. On such a problem where you're estimating the natural log of something, the first thing you do is say, I understand that the natural log of 3 is the area under the curve from 1 to 3. Now, at that point, then, I can use an x dx if you like there. You can use t, it's fine, it doesn't matter. But that's what you're trying to do. Again, have your eyes open, all right? You want to, I had people do this. I think, all right, they're wrong. And what did they do? They actually integrated it. And they got this. Well, you're right. I don't know what you go from there. You said that something equals itself, which is true, but I don't know where you're going to go from there, right? So, no, the idea is you estimate this. They said, oh, that gets me rolling because it made them able to estimate it with something that wasn't funky, transcendental. It made it a 1 over x kind of function which people can do without a calculator. That was the step forward, all right? So you then have to determine, well, how many trapezoids do I need to get a good estimate? You would be given how close I want it. You can bet on the test tomorrow. It would involve a fairly small number of trapezoids so that you're not wasting your time. Understood? Are you good here? You better
Will you be giving us
keep going here.
max trapezoid?
So say I had the error is, I estimate this, the question would be estimate this error less than For that, I'd say maybe less than 1/3. Okay, now you'll see that that will involve a very small number of trapezoids. Say this was the question. Let's just at least get to the point where you say, I got it from there, all right? So what would you do?
Use the
I will give you the error bound. You would need to find the number of trapezoids to get the error within, all right? So you'd say something like the error is less than b minus a cubed over 12n squared, max of f double on a to b, which has to be less than 1/3. Okay, notice where that 1/3 goes. It doesn't go there. It is not the error. I don't know the error. Okay, I'm bounding the error. So what's b minus a? 3 minus 1 or 2 cubed over what's in? We don't know. What is the max double work out to be in these? If you know that 2 tomorrow, you'll save yourself some time. I do not need to see the work. If you just throw 2 in, I'm fine. 1/3. If you isolate n squared, then you're going to move the 3 over there. You'll have 2 times 2 times 2 from that, times a 2 from that, times a 3 over 12. Clean that up a little. There's a 12 here. So n squared, let's say error less than, actually that's fine. So error n squared is greater than 4, so n must be
5.
greater than or equal to, how many trapezoids do you need?
2.
No.
1.
No, you are killing me. 3. N squared is greater than 4, means n is greater than, not equal to, greater than 2. So you need
3.
3. All right? All right. Is that understood? I'm frustrated already. I don't even want to grade these things. I should just make an easy test. That's all. Okay? No. Partner test, no. Partner quizzes next week. We'll see how disastrous that goes. All right. It actually goes pretty well. I'm real sorry. Sorry. All right. Polar. Are you ready for some polar action?
The differentials are those, I mean, is this whole thing no calculator?
No.
I always,
No, how about when I was?
probably never.
Okay. How much color do you remember?
0.
How much color have you learned? Okay, now I'm not going to hit, the good news is I'm not going to do all polar, everything you ever learned in one day. I'm going to break it up. So today you're going to do point basics, equation basics, and 3 types of graph. So here we go. The whole idea is that you can give directions to any point in space in 2 dimensions. In 3 dimensions, this is called spherical. But in 2 dimensions, you can get a direction to that point in 2 ways. You could say, hey, from the origin, go right 3 and up 3. That is called rectangular. It then involves, in terms of what kind of graph space would be helpful to locate such spaces, surely they give you help by using a grid. That makes it easy to find space, or points in space. That's sometimes called taxi-cab geometry, because if you were to go from here to there, in a taxi-cab, you would have to follow the streets in a horizontal and vertical fashion, right? Polar is more like as the crow flies, which is to say, if I wanted to get to this here point, I could say, all right, first, imagine the person's at the origin. First, we always consider in math that you're starting looking east or in the positive x-axis. First, I want you to face where I want you to go. That involves turning some angle. If you turn up from the x-axis, then theta is positive. If you turn down, theta is negative. Okay, now we've turned and now we're still at the origin and we're looking in the direction we want to go. The next thing you'd want to give directions is now go forward this much. R is the distance you travel. If R is positive, then you are going to go forward. If R is negative, then you are going to be looking in that direction, but you're actually going to end up behind you because you're going to go backward. Now, because R and theta both have two possible options, then we have four possible combinations of directions. You can get directions to any polar point by a positive R, a positive theta, a positive R, a negative theta, a negative R, a positive theta, and a negative R, a negative theta. I guess I could have done that in a grid kind of idea. Are you with me? Now, say I looked at this same point. I wanted to get to this point 3, 3 in polar. Let's put 3, 3 in polar. 4 ways. Okay? What's the most logical angle to turn to face that direction?
45.
In radians. Pi over 4, okay? Because 3 and 3 are equal, it's an isosceles triangle, it must be 45 degree angles, and therefore pi over 4. The angle, although the angle is really the first thing you do, it goes second in the 40. Pi over 4. And how far forward would we travel? 3 root 2. Now that's if, again, if I faced that point and went forward. Boom. There's another way I could do it. If I were to draw the picture, I could actually turn the other way and go way around and then go forward. What would that be? 3 root 2 because I'm still going forward. And then the angle? Negative 7 pi over 4. Notice that the positive angle and the negative angle should all together make a full circle. So they should always add to 2 pi without the sign involved, right? Between the two of them, they should make a full circle. Yeah? What about if I took the rather counterintuitive approach of wanting to get to this point, but facing the opposite direction and then backing up to get there? First of all, what angle would I turn in a positive way to face the opposite direction? 5 pi over 4. Notice that it is exactly pi across or away from the original version. But I am going backwards 3 root 2, so that means negative 3 root 2. I'm going a negative distance. The last possible option is to go what? To turn which way and go forward or backward which way? Turn in a negative direction, which is to say turn down from the x-axis and then back up. What would that coordinate be? Negative 3 root 2 for backing up, and the angle? Negative 3 pi over 4. Okay. Now, let's be clear. All these 4, 5 points are the same. They're just different ways of doing it. Let's also be clear that although this graph here with a grid and this graph with the circles look totally different, it's still two-dimensional space of x and y, and that's still a point in the planar space. The reason that the graph space is given differently is because if I want to go forward in any direction out from the origin, then distance from any point going up needs to be a circle. And so that it's not that this space is different or this is a totally different, it's still the same point. It's just they're giving you a little different help in getting there by giving you circles rather than a grid. A horizontal and vertical grid would help you in total. With me? Okay.
Mr.
Yep.
Can you explain where do you get this 3 root 2 from?
Pythagorean theorem or 45, 45, 90, the reference triangle is that. So if it's multiplied by that. Okay?
Okay.
Other questions? Okay. All right then. Would you tackle the table, please? Do you understand what's being asked? Okay. I'm giving you either one rectangular form and asking you for 4 different polar forms, or I'm giving you one of the 4 polar forms and asking you for both rectangular and the other 3. Would you like to do one together? Sure. Okay, so let's do this one. If I were to locate this, where is it? 4 at an angle of negative 3 pi over 2. Do the angle first. Don't do the 4 first. You don't know what direction you're going. You would first figure out what direction you're going. So what direction are you going to be pointing? Up. You're going to be pointing up. You're going to be focusing. You're going down because it's a negative angle, but 3 pi over 2 would put you here, yeah? So you're going that way 4 units. Okay? Now that is the positive R, forward and turning down kind of way. So give me this version. What if you went, instead of turning down, you went turning up? What's the positive theta? Pi over 2, and forward would be positive 4. Now, these involve negative arcs, so these involve backing up. So those would mean that if I want to end up here, I really need to face here. There are 2 ways to face down there, either turning down and looking that way, or turning up and looking that way. So what about the positive theta? What angle would you have to turn to get the positive theta? 3 pi, it would be 3 pi over 2 to face that downward direction, but then we would back up by doing a negative 4. Or we could, from the x-axis, turn down, and that would be negative pi over 2, and backing up again would require a negative 4. What about the rectangular form of that? What's the x and the y of this point? 0. Okay, do you understand what you're supposed to do? Okay. Feel free to talk more with your mathematicals. Yes?
The bottom right-hand corner is
Oh, you're right. That, yeah, sorry, would you throw it? You're right. That should be a negative 7 pi over 4. Thank you. You're correct. Is that your- I just looked at the graph, really. I said, if I was facing this way and up 4 units, that would put me at the x-axis, or the y-axis. Why? Now, why would you do that when you could just?
If you don't, yeah, no,
no,
but
the picture.
yeah. So
Oh.
what if you're at like 2 pi over 3?
Then you do two cosine of pi over 3 for the x, and then you do 2 sine pi over 3.
These are the ones that.
You're right. Maybe for conversion's sake, I was actually going to tackle this below this, but you're right. To get to the rectangular, maybe we should do this real quick. Can I pause and jump ahead a little in the lessons real quick? Sorry. Would you jump to this here, right below that table, please? Sorry, I'll switch order. You with me? You see where I'm at? Okay. This is the key that governs the whole relationship between x, y, r, and theta. If you draw a triangle, then obviously this is x, this is y, this is theta, and the hypotenuse is r, right? Okay, now from that you can actually get several facts. First of all, x squared plus y squared is r squared. it's easy enough to see that cosine of theta is adjacent x to hypotenuse r, but more useful is that x is r cosine theta. And by a similar thought process, y is r sine theta. And as far as relating theta to x and y, tangent of theta is y over x. These four equations are gold in terms of going from one form to the other. Okay, that might help you, especially these two might help you in going to the rectangular part of the table when you need to. So now let's work. I'm going to get some water.
Okay, so this is what it is. Great, so
It's like this.
this is the theta right here, right? Okay, this is the one. Yeah. I know. Okay, put that line.
Wait.
I don't know where negative 1.2. Okay, so then for a positive theta. I would do it in
How'd the first row go?
So bad.
How do you do that?
I don't understand.
Okay? All right? So this is the picture of that point. Do you agree? You said they don't understand. Am I wasting your time? Never mind. Okay? So there's my picture of that point. Do you agree? Okay. So you first need the related angle. Theta is the inverse. I didn't even sweat signs. I just said the inverse tangent of 7 halves or 3.5.
I got that was about 1.29-ish, and I stored that to A, because I'm going to need that over and over. 1.292.
Wait,
Yeah, I got that.
is it tangent theta or x and y or y?
Y over X, Y is opposite.
Yeah.
Okay, so as far as this angle, how would I use this? This angle is in here, right?
From what?
So how do I find this angle? Pi minus, that's where I got this angle.
Oh,
Okay? How would you find this angle?
pi plus.
Pi plus it. That's how I got that. And it's negative because it's going up. Okay? So are we cool on these two?
Yeah.
Okay? These two then, the other way are backing up this way. Now, the easiest one of all is just this way, which is negative A. That's where that's. How do you find this one?
3 pi over 2. Or, no, 2 pi over
2 pi minus. Okay.
For positive.
In all cases, you should never be using pi over 2 and 3 pi over 2. Never. Always using pi and 2 pi as reference points. You're never using the y-axis as a reference. Okay, other than just telling you if you're in the right direction. All right, is that cool?
So why do you know that you have to add pi to the negative?
Just based on what quadrant they're in. Like, are you talking about this example?
No, so I got the negative 1.29, that thing. But how do you know that?
First of all, make it positive. Don't use the sign will screw you up, so leave it positive. Don't do inverse tangent of 7 over negative 2. Just do inverse tangent of 7 over 2. Okay? Second, then I go based totally. I just know that the triangle is 1.292, and it's all based then on the quadrant. If I want this, then it would be total take away that angle. That's why I did pi minus. If I did this one, then it's more than pi, so it's pi plus.
Okay. So the 1.292 is always just what's in the triangle.
In the triangle, exactly.
So if you take the absolute value, inverse tangent absolute value of y over x.
I just, yes, that's true. I just ignored the sum. Okay? This is obviously a 30, 60, 90 kind of triangle, and it feels like a 60 or pi over 3. Yes? Nope, it doesn't. It feels like a 30. Okay? So, I'm looking at this being, and multiplied by a scale factor of how big? Normally those are just root 3 over 2, just 1/2. How many times bigger is this case? Scale factor of 3. So instead of going the unit circle hypotenuse of 1 unit, it's actually going to go 3 units. So every one of these is 3. You could get that by Pythagorean theorem if you want to work too hard. Okay? Are you with me? If this puts me in this kind of situation where the angle is pi over 60, then what's the positive angle? 5 pi over 6, and the negative angle? Negative 7 pi over 6.
Wait, isn't it in the fourth quadrant?
Oh, I put the negative on the... You're right. Thank you. You're correct. Sorry. It's taken longer than I expected. You're correct. It is in the fourth quadrant, but do you agree with the 30-degree or 5 or 6 related angle? Okay, so the positive, I apologize, is positive 11 pi over 6. The negative is negative pi over 6. The other quadrant is positive 5 pi over 6 or negative 7 pi over 6. Success? Good. Okay. 2 pi over 6 is there. It is the same in rectangular as the unit circle, which is normally root 3 over 2, 1/2, 1, but multiplied by a factor of 2. So instead, the x will be root 3, and the y is 1. In terms of the other directions, if I went this way, then that's an angle of negative 11 pi over 6. If I was facing the opposite direction, then I'm in third quadrant, which is either 7 pi over 6 in the positive form, or negative 5 pi over 6 in the negative form. How we do there? Okay, you get the idea. In the interest of time, let's move on. So, let's go to converting not points, but equations, right? Now, there's a bit of a trick here with experience you're going to gain. Substitution can be used pretty well here, but here there's a bit of a trick. So, if I use these relationships to bridge from rectangular to polar, then I could do it by substitution. In place of y, I could use r sine theta. And in place of x, I could use r cosine theta. It is expected that you will solve for r in most cases. If I don't say, then it's assumed, yes, you do solve for r. And only if I say don't solve for r, then you shouldn't. But in this case, you should. If I solve for r, I can subtract that over, factor out, and divide over, and so r is 3 over sine theta minus 2 cosine theta. Okay? This one, there's a bit of a trick. Again, I could substitute the square root of x squared plus y squared. And then in cosine, I could put something in. There's a better way. If only r, think multiplying. What would be great to multiply by? Multiply by r. R, with emphasis, not r factorial. Don't multiply by r factorial. Okay? If I multiply both sides by r, then I am in oh so much luck. R squared is x squared plus y squared, and 3r cosine theta is 3x. Now, normally then I would complete the square, put this in standard form. What is this? It's a circle. Okay, but we'll leave it like that. Okay, are you with me? Okay. Circles. Speaking of circles, there are 3 forms of a circle. Start with r equals 3. If only r equals 3 is given, then what can theta be? Anything. So if theta is 0, what's r? 3. Go out forward 3. If theta is pi over 6, what's r? 3. 1, 2, 3. Go forward 1, 2, 3. If r is pi over 3, theta is pi over 4, what's r? Okay, so what do I get if I'm always going out 3? A circle centered at the origin. Put that in your notes first, please. If you have r equals a constant a, then that is a circle centered at the origin with radius equal to a. What about r equal 3 cosine theta? At 0 radians, what's cosine? 1. What's 3 times 1? 3. At pi over 6, what's cosine? Root 3 over 2. Would you please put up here, root 3 over 2 is about what is it, 0.8-ish, 0.9-ish? What is it? Something like that.
I got the calculator.
I think it's 0.85-ish.
We could estimate
0.85-ish, 86-ish. Okay, so 3 times 0.86-ish, it's about out 2.7-ish. Okay? At pi over 4, what's cosine? Root 2 over 2. What's root 2 over 2 about? 1.4 divided by 2, which is about 0.7. So it's 3 times 0.7, about 2.1. At pi over 3, what's cosine?
3. No, 3 what? 1/2 times 3 is 3/2. At pi over 2, what's cosine? 0. So I'm getting like this, yeah? Here's where it starts to get tricky. At 2 pi over 3, what's cosine? Negative 1/2 times 3, so negative 3/2. I'm going to face this angle, but if I have an r of negative 3/2, I go backward. So I'm actually going to go backward into the fourth quadrant, 1.5 units. This, we said, was root 2 over 2 negative, which is 0.7, times 3 is 2.1, but it's all negative. So I go back 2.1, which puts me in the fourth quadrant, about 2 units out. And then about, whatever I said, what was 3 root 2 over 3, about 2.7-ish. And then at pi, what's cosine of pi? Negative 1 times 3 then is negative 3. So I get a circle. Now it's important to know that just because I got a complete circle doesn't mean I couldn't do points here. But if I did points, you'd see backing up, backing up, backing up in here, and then forward, forward here. You would see the exact same circle retraced again one more time. So it is a circle. R equals A cosine theta is a circle, symmetric at the x-axis with diameter A, not radius. Diameter is A. In this case, when I had 3 cosine theta, the diameter was 3.
What does it mean symmetric at the x-axis?
There's mirror image along the x-axis that is symmetry there. Okay, what about 4 sine theta at 0? 0 at pi over 6. 1/2 times 4 is 2. Okay, root 2 over 2 is 0.7 times 4 is 2.8. Let's go with 0.9-ish at root 3 over 2 times 4 is 3.6. And at pi over 2, cosine is 1 times 4 is 4. Notice that there's no backing up there. Will there be backing up in the second quadrant? Why not? The sign is positive there. So sign is positive, so I'm still going to be going forward, forward, forward. And then once I start facing angles in the lower quadrants, then I would be backing up over the circle again. But I get a circle. When I do r equals a sine theta, I get a circle symmetric at the y-axis with diameter equal to A. That said then, if I throw like, hey, graph r equals 6 sine theta at you, I don't expect you to make a table. I expect you to take 30, and actually make that 1 second. Boom, circle symmetric at the y-axis with diameter A. Check. Check. We'll graph. We'll do the other parts of the notes on Wednesday, I suppose. Ay, ay, ay. Yeah. If you finish the test, you can finish the notes tomorrow. Have a nice day.
Mr. Rickman,
Yes.
would you be willing to require me for service?
Sure.
Thank you.
You're welcome. You're already full? Yes. Am I already full? All right. Here we go. Requiring 7th period people.
And then I also have an absence sheet for Thursday and Friday.
Ooh.
Actually, I might miss Wednesday in this class too.
You're welcome, Bob. Yeah. So how many people, who said that? CC Jack. Thank you. CC Jack Harmony, 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 CC Jack Harmony,
I have this for you.
CC Jack Harmony, CC Jack Harmony.
I didn't realize I forgot to turn it in.
Come on.
I'm sorry.
Thank you for telling me in person. CC Jack Harmony, 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 CC Harmony, Jack. Have a good day. Thank you. You're welcome. Have a great day. Shabby.